And today I'm going to be talking about Newton's law of cooling. So his formula is T plus equals tangent plus TO or 2 minus tangent E minus KT. So to explain what these T's and tangents and all this is, T plus is the current temperature, tangent is the temperature of the surrounding room, T is the initial temperature of the object, and K is the constant of the proportionality. T is the time since the object was removed. So if you don't get this, let me put this into an example because I believe it's easier like this. So this is what we're going to be working with. The room temperature and the time was 84. The initial temperature was 160. After 2 minutes of it being out in the room temperature, it hit 145. So let's put this in a question. You make mac and cheese. It comes out at 160 degrees. After sitting in a room for 2 minutes where the temperature is 84 degrees, the mac and cheese is now 145 degrees. Create a model to find K, and when will the mac and cheese be at 127 degrees? So there is 2 questions. First, you should try to create the model to find K. This is the first thing you should do before trying to find out when it'll be 127 degrees. So here I already created the model. 145 is how it was already after it being out. 84 was the room temperature. 160 was the initial. So this was the moment it came, the moment it was finished, right after. And yeah, and 2 is, by the way, is the minutes. So right here it's algebra. You just have to lower this. So 84, this gives you 61, and then right here you also do you already do it because it's just in parentheses subtracting, which gives you 61 equals 76 E of minus K and 2. Now from here it's even more. You divide 76 because 76 is, well, technically multiplying with E and this. So you have to do the opposite, which makes you divide. 61 divided by 76 is 0.80, which is now left with E minus K2. Now to get rid of E, you have to use the natural log, and you just log both sides, which leaves you with log of 0.80 equals, because this crosses out, minus K2. And from here, well, actually, matter of fact, you can switch this around, which it seems to be easier, minus 2K, because you're multiplying it doesn't matter because of a property. And now, once again, you divide, and dividing this entire thing gives you K, which gives you 0.11. So now, just like that, we found K. It's mostly just getting rid of the numbers to where you're left with K, and it's K equals 0.11. That is now the first part. And now to find when the mac and cheese will be 127 degrees, you now use K to find T, and right here I wrote down the equation already. We're substituting 127 for 145 because we're trying to figure out when it'll be 127, and since we have K, you put it in already, and now we're trying to find T, so we're trying to find out when it's going to be done. And this is the same scenario. You subtract 84 from 127, gives you 43. And obviously we already know this is 76 E minus 0.11 T. Once again, you divide. This will now give you 0.56. By the way, I already put this on a calculator, so I know this is for sure correct. E minus 0.11. Then once again, you have to log it to get rid of the E. Oh, the 2. Cross that out. Boom. A boom. That leaves you with log of 0.50 equals negative 0.11 T. Then, like before, the final step is you just simply divide to cross this out, do all of this, and this gives you T equals, because we're trying to find T obviously, 5.27. So pretty much in 5 minutes and 27 seconds, the mac and cheese will be 127 degrees. And like that, you can figure out whenever the mac and cheese is going to be whichever temperature you want, on whatever you want, but it's only cooling. You cannot obviously add it unless, well, there's a different formula for that. But that is basically it. And yeah, and just to show Herrera that this is me on camera, and just, oh, all right. Thank you.